Today, I'm going to show you how to unpack terrain textures and start building a simple terrain layer shader. Let's go. So, we're just getting started with a new tutorial series of creating terrain shaders in Unreal and Unity. Last week, I talked about making a plan, finding reference images, and identifying materials you'd like to use. The homework assignment I gave was for you to find your own set of terrain textures. You could either make your own or find some online resources like at textures.com, Epic's Fab Store, Unity's Asset Store, or others. Let's start today with a look at the textures that I've selected. So we're going to switch over to Substance Designer here, and I'm using Substance Designer because I like to use it for packing and manipulating textures. You know, you're welcome to use whatever photo editing software you like, but I'm kind of partial to Substance Designer. So let's take a look at these textures that I've selected. The first one is a dry soil texture. It looks kind of like this. And when you pick texture sets, usually what you'll get is color and normal, and then like all of the other masks. So this one is the roughness. This one is the specular level or the crevice map. Here's the ambient occlusion, and I also have height. So I'm going to get all these different masks for the texture set that I've selected. And here I'm using Substance Designer to pack them together. So I made a new node called Make Material for Unreal, and then another new node called Make CRNOH. And these are specifically for packing the channels. So I have all these maps separated here. And what these nodes do is organize the data correctly for each of the two game engines. So this one, if we just take a look at what's going on inside this network, you can see that really all it's doing here is flipping the green channel of the normal map. And then down here, it's just kind of adjusting the height map a little bit. So that one's not really doing all that much, honestly. But then this one is actually packing the channels. So it puts the color into this texture here with the roughness in the alpha channel. And then it puts the first two channels of the normal map into the red and green of this second texture, puts the occlusion in the blue channel, and the height in the alpha channel. So that's how I'm packing my textures. We talked about this a bit last week as well. So we have this texture format here called CR and NOH. And then for the Unity version, Unity textures are pretty much exactly the same as Unreal. The only difference is Unity uses smoothness instead of roughness. And so if you get roughness data from your source, you can just invert that channel to get the opposite of roughness, which is smoothness. And so here I'm packing a CS texture for color and smoothness instead of color and roughness, and then my NOH texture. And the difference between normals in Unity and normals in Unreal is that the green channel is flipped. So if we take a look at our normal map for Unreal, we can just take a look at our green channel here. You can see that it looks like things are being lit from underneath, like there's a light source coming from the bottom. And if we look at that same channel for our Unity texture, this green channel of the normal map, or the Y component of the normal, is being lit from the top. And so whenever you have normal maps for Unity, make sure that the green channel looks like it's being lit from the top. And for Unreal, make sure it looks like it's being lit from the bottom. And anyway, all I've done is set up this network in Substance Designer to pack those textures together, and then I'm able to easily export them to both Unity and Unreal. And I'm using the same set of textures for each engine, just with those changes that I described, just with the flipped normal map and with smoothness or roughness where it's applicable. All right, so if we take a look at this, you can see the materials that I'm using are this dry soil. And the thing that I really like about this one is I'm able to use wetness decals on it to also make it look like it's mud, to look like wet soil. So that's kind of cool. I've only picked 4 materials here. The shader that I'm going to be working on has 4 layers, and I really like to keep my layer count low. Like, you might think, oh man, you only have 4 material layers. Well, the fewer layers you can make on your terrain, the better the performance will be. And so I try to keep my layer count to a minimum for better performance. And what I like to do is pick kind of versatile materials that I can blend together to make variations of them. So let me show you what I mean. So here is my next material. This one is just kind of a mossy grass. So if we take a look at our color map here, you can just see it's just kind of like grass and moss mixed together. Let's take a look at it in our 3D view here. I can just kind of tumble it around. So the nice thing about this one is that it's just this mossy grass, and I can blend it with that dirt to get sort of a dirty mossy grass. Let's take a look at my third one here. This one is kind of a rocky grass, and this is also another good one for blending. So I can blend this one with the dirt, or I can blend this one with that other mossy grass to get some really nice variation. So we looked at reference images last week of the forest stream, and what I'm going to end up doing is using this material on the banks of the stream. So the stream is kind of at the bottom, and then I'll have these little banks going up the sides, and then sort of a flat on the edges above the banks. So this is going to be the material that I use on the banks. And then my fourth material here is going to be my kind of rounded cobblestones, and they look like this. So if we take a look at this material in our 3D view, yeah, this one's pretty cool looking. And this is what I'm going to use for underneath the water in the stream itself. You know, in the reference that we looked at, we identified that the stream itself had these kind of really rounded cobblestones, and this one looks especially good when it's blended, when it's height blended with that dirt that I showed you. So if we make our dirt look wet and then use height blending, so here's our height for our cobblestones. If we just fill in all these crevices with that dirt, we can get a really nice hybrid material between our stones and our dirt. So we're going to be doing that later on in this series. All right, so these are the 4 texture sets that I've selected. And what I want to do now is show you the textures in the engine itself. So let's switch over to Unity, and then I'll show it to you in Unreal as well. So in Unity, I have my terrain textures here. Here's my dry soil CS. And one of the things that I discovered with this particular texture is that almost all of the detail is in the normal map. And so what I did, I got my source textures at resolutions like between 2048 and 8192, like 8K textures, really, really big source. And you definitely do not need that in your game engine. The biggest you should make your terrain textures is 2048. And a lot of times you can get away with making them smaller than that. And that's what I discovered in the case of this dry soil texture. I found out that if we're looking at the normal data, like most of the detail of this texture is in this normal data. And if we look at the color data, it's mostly just monochromatic. And so I actually knocked down the resolution of the soil to 256, and it doesn't really make that big of a difference visually. This is what we're looking at right here, and I'll show you how to build this shader in a minute. But so we're looking at this soil texture, and it looks pretty detailed because our normal map is 2048, but I'm able to get away with keeping the color map at just 256, save some texture memory, and it still looks great. So let's take a look really quickly at the settings all of the textures that we're using today need to be saved in this BC7 texture format. And the way that you do that is here under the compression setting, you just set compression to high quality. And if you in Unity, if you set it to high quality, on platforms that support the BC7 texture compression, it's going to use that texture compression. And the other setting for my color map is that I have it set to sRGB. So my color is set to sRGB and compression set to high quality. And then for my normal map, usually for a normal map, you would think that the texture type should be set to normal map. But no, in this case, it needs to just be set to default. And the reason for that is that I'm storing other data in the normal along with the normal data. We're storing occlusion and height data in there. And if you save it as a normal map, it'll get rid of that extra data and just save your normal data. And I don't want that. So instead of saving this as a normal map, it needs to be set to default. Now this is really important. It needs to have this sRGB box off. So sRGB needs to be off, and the texture type needs to be set to default, and the compression needs to be set to high quality. All right, so for color, we have sRGB on and compression set to high quality. And for our normal, our NOH texture, make sure it's set to default. sRGB is off, and our compression set to high quality. So I've gone ahead and done that for all of our textures. Let's go ahead and switch over to Unreal, and I'll show you the same things there. All right, so here are all the textures that I brought into Unreal. Let's just take a look at these really quick. I'll double click and open up my soil texture. Here you can see, again, I was able to take this soil texture and reduce it down to just 256 because of how little of the detail is actually stored in this soil color texture. So our original texture, it says imported here, is 8192. So that's an 8K texture, way too big. And I was able to shrink it down in-game by just setting my LOD bias to 5, which means it's jumping down to LOD 5. So if I set LOD bias to 0 here, you'll see that it's jumped way up to 8K again. If I set it to 1, now it's going to be 4K, 2 is going to be 2K, but in this case, I know I can get away with setting this to 5, save a ton of texture memory, and just keep this color map as a 256. All right, other settings that are important. We've set our compression settings to BC7, and we've set our sRGB to on, because color needs to have this sRGB gamma correction. All right, let's take a look at our normal maps. So here's my soil normal map. And again, we started out with a texture that's 8K, but we set our LOD bias to 2 so that we skip the first 2 MIP levels and just go directly to 2K instead. And I'm keeping this one at 2K because that nice crunchy normal map detail is what's important for this dry soil. Okay, again, you can see our compression settings are set to BC7 and our sRGB is off. That's very important for normal maps. All right, so I've gone ahead and done that with all of my textures. I set my LOD bias according to how large the resolution needs to be. And again, make sure, don't use textures over 2K. That's just a waste of texture memory and resources. For all of these textures, I set the compression setting to BC7, and I set the sRGB on for color textures and off for the normal map textures. All right, so that's it for the textures. You can see I've imported all of these into Unreal as well as in Unity. And actually, you know what? Let me show you one more thing. I did give you that homework assignment last week to select the materials you wanted to use for your terrain. And to go ahead and download those textures and then pack them into CS and NOH for Unity. and CR and NOH for Unreal. But if you're one of those lazy kids who doesn't do your homework, let me show you a quick shortcut here, a little cheat that you can use if you want to just use the materials that I'm using. So here in Unity, I'm going to come up under Window, Package Management, Package Manager. And here, if I select In Project, it's going to show all of the packages that are installed in my project. And if I select Shader Graph, and then I scroll this down to Production Ready Shaders, this is a set of sample content that contains the textures I'm going to be using in this series of tutorials. So if you just want to download Production Ready Shaders, this sample comes with all of the textures that we're going to be using today. So I really encourage you to go out and find the ones that you want to use and pack them yourself, just for the experience of learning that process, and so you can make a terrain that looks a little bit unique from the one that I'm building. But again, if you want to shortcut it, you don't want to do your homework, you can download the same textures that I'm doing from, or that I'm using from the Production Ready Shaders sample in Unity. All right, so the next thing that we need to do is bring these textures in. We've got them in the game engine now, and so we need to start building the shader that uses this texture data. So let's do this in Unity first, and then we'll switch over to Unreal in a minute. All right, so I've created a new folder here that's just called Terrain Shaders, and all of the work that we're going to be doing in this series of tutorials is going to be in this folder here, Terrain Shaders. So what I need to do is make a new subgraph that's going to be the layer that has my material in it. So I'm just going to right-click in here and pick Create Shader Graph Subgraph, and I'm just going to call this Simple Layer, and we'll open it up and just get started creating our shader. So the output of this subgraph is going to be a material. It's going to be the dirt or the grass or the rocks. And so let's first start out by setting up the outputs for our material. So I'm going to open up my graph inspector with my output block here selected. And the first thing that we're going to output, now this is kind of interesting. You may not have seen this method before, but I'm going to make an output that's called material, and I'm going to set it to a matrix 4. So a matrix is a list of vectors that are like in a stack. So material 4x4 here is now a set of 4 float 4s. And what I can do is I can pack my entire material into that so that I can pass all of my material data, my smoothness, my normal map, my ambient occlusion, my color, all of that data I can pass around in one wire. So that's what we're going to be doing. It's kind of cool. I'll show you how it's set up in a minute, but let's go ahead and finish adding the rest of these material properties. So we're going to pass everything out in our material wire. But then just for convenience, I'm also going to split these out into their individual components so that you can access the whole thing if you use the material output. But then you'll be able to access each individual component as well if you just grab the one that you want. So we're going to make color a vector 3. We're going to make normal a vector 3. We're going to make metallic. And that's going to be a float. And actually, we're not going to use metallic. Nothing on our terrain is metal, but just for flexibility. And so in case you actually need something that's metallic on your terrain, I'm going to include that in there. Okay, so next we're going to do smoothness. And we need an occlusion. And finally, we need a height. So these are all of the properties of our terrain material. And this is what our layer subgraph is going to be outputting. Okay, so we've got all our properties there. Let's see. The next thing that I want to do, I want to show you this brand new feature in Unity 6.3. Unity has just recently added the ability to support terrain shaders. And if we open up our Create Node menu here, you'll see there's this new category called Terrain. And inside here, there's this Terrain Texture node. This is a brand new node in Unity that allows you to bring in data from the terrain. So let me show you what I'm talking about. If we switch back here to our scene and I pick my terrain, here on my terrain panel, I can set, if I switch here to paint terrain and then set this drop down to paint texture, it's going to give me a list of layers. And I've gone ahead and created a layer here, but let me just remove this so I can show you how to do this from scratch. So let's say this is a brand new terrain. I've never done anything on it. And it wants me to add some layers in this layer palette. You know, here it says list is empty. I'm going to add a new layer. And I'm able to pick layers from this list. So let's just use our dry soil layer here. And so I've created a new layer. And my layer is showing up here under my terrain shaders folder. If I select this layer here in the project window, you can see that I've already set up my CS and my NOH texture. I've put CS in the diffuse slot. I've put NOH in the normal map slot. And then my layer comes with a bunch of other properties. So it has a normal map scale, like if I want to strengthen or weaken the influence of the normal map. It has a specular color value, a metallic value, a whole bunch of values here. And what I am going to recommend is that you not use any of these. For example, normal map scale, what this is doing is it's doing some math in the shader to strengthen or weaken the normal map. And that's doing that math every pixel, every frame. And this is something that you can do in the texture in the software that you use to create your texture. So for example, I could switch back to Substance Designer and strengthen my normal map there and then re-export the texture. That takes a little bit more time and development, but it's also saving performance because if I'm using this normal map scale value here, I'm actually doing that math in the pixel shader instead of offline in my texture editing software. And basically all of these parameters here, you know, my scaling and such, all of these parameters are doing a little bit of math. And if you can avoid doing math, you can improve performance. And so it's possible to build a terrain shader that supports all of these properties. But if you leave them out, you can make things go just a little bit faster in terms of performance. So that's what I'm going to be doing. So really, all I need for this terrain layer here is just the diffuse map and the normal map. And I'm going to kind of ignore all of the rest of these properties. But what I wanted to show you is the properties that show up here are also available here on our terrain texture node. So the normal scale, the defaults for metallic and smoothness, the color tint. If you want to create a shader that supports all of these features from the terrain layer, you can bring all of these into your shader and you can set them up the way Unity intends them to be used, or you can use these values for whatever you want, really, because once you bring them into the shader, what you do with them is, you know, whatever you choose to do with them. All right, but mostly what we're interested in with this terrain texture node is this texture asset output here. I can use this drop down to select diffuse map, normal map, mask map, and then the other maps as well. In this case, let's use the diffuse map. So I'm going to bring in our diffuse map asset, and I'm going to use this node called Split Texture Transform, and we're going to plug our diffuse map asset into that. And that's going to give me the tiling and offset values from this map, plus the map itself. Now the tiling and offset values come from right here. So I've already kind of lied to you just a little bit. I told you I wasn't going to use any of these properties, and I am actually using the tiling and offset values. So size and offset, we have values of 2 here by default, and I am actually using those. All right, so what we can do with those is they come in with the texture, and then I can add a tiling and offset node and connect up our tiling and connect up our offset. And then we can grab the texture itself and add a sample texture 2D node. And we can plug our texture asset directly into that. And then we can plug our tiling and offset node into our sample texture 2D. All right, so this texture, if you'll remember, has our color in the RGB, and it has our smoothness in the alpha channel. So for our outputs here, I can just grab the color and wire it into color, and I can grab the smoothness and wire it into smoothness. And we're about half done with our material unpacking. Okay, the next thing that I want to do is bring in our NOH texture. And so again, I need another terrain texture node here, so I can just copy and paste this one. And instead of setting this one to diffuse map, I'm going to set this one to normal map. And again, this corresponds to, so here's my terrain layer that I created. Here's our diffuse map and our normal map. So if I pick normal map in this drop down in our terrain texture, it's going to give me whatever data is plugged in here in our layer. Okay, so again, I'm going to use our split transform node, wire in our terrain texture. So that's going to give me my normal map. And then I'm going to sample my normal map using the sampler just like that. Now here's a cool performance saving feature. I'm using the tiling and offset from my diffuse map here and calculating that tiling and offset here, but I don't need to do that again because I know that the diffuse and the normal map are always going to be matched. So in other words, they're always using the same tiling and offset. So I only need to do that tiling and offset once here, and then I can just pass that same value into both textures. Okay, and then finally, I need to unpack the data in my NOH texture that I'm getting here. So we know the normal map is in the red and the green. The occlusion is in the blue, so let's wire that in. And then the height map is in the alpha, so we can wire that one in as well. And it looks like we've got everything here except for our normal. So let's talk about this. Normally, when you use a normal map, you set the sampler type to be normal. But remember, my normal maps are not set to be normal. They're set to be just a default type. And that's because I didn't want the normal map to throw out my occlusion and my height. And so I need to do a couple of little special things here to handle my normals so that I make sure that I get them unpacked correctly. First thing that I'm going to do is add a vector2 node, and I'm going to pass in my red and my green channel of my NOH texture there, just so I know I have my X and my Y now. And then the next thing that I need to do is regenerate the Z component, and I can do that with my normal reconstruct Z. And what this is doing is it's using the Pythagorean theorem to take my X and my Y. I know that my final vector is going to be a length of 1, and I know what my X and my Y value is, so I can do a little bit of algebra and figure out what my Z value is here. And I have a couple of secrets to share that not everybody knows. You might think, well, hey, you know, you're doing this, you're putting your normal, you're putting your occlusion and your height into your normal, and because you're not storing the Z component now, you've had to calculate it in the shader. Isn't that like that's more expensive than if you're just using a regular normal map? Well, here's the secret. If you use a regular normal map, and you set that texture to be a normal. So here's my normal map. If I set this texture to be a normal like this, and I set my sampler to be also a normal like this, what I'm doing here to reconstruct the Z component is done automatically. This is already happening. So when you set a texture to be a normal map, it's only storing the X and the Y channels. And when you bring it into the shader, it's reconstructing the Z for you, but it's doing it under the hood. And most people don't know this. So this math that I'm doing here to unpack this texture is something that happens already. So we're not actually incurring any additional cost by doing this. Because the engine is already doing it for you when you use a normal map. It's just not telling you that it's doing it. So like I said, we're not doing anything extra. Okay, so I'm going to set this back to default. I'm going to set this back to default. Okay, and I do have one extra secret to tell here as well. So this node here is doing a little bit of extra math, specifically in order to recalculate the Z component of the normal. It's doing a square root instruction, which is a little bit expensive. So if I pass this out, that will be great. You know, it'll work fine, and it'll be really nice quality because I've got my really nice X and my Y, and then I've got a really nice and accurate Z component of my normal map because I'm using that square root instruction. But I'm going to show you a way of making this a little bit cheaper. And what I'm going to do, and this is possible because normal maps on terrain are generally mostly flat. You know, you can see here that if I look at this, there's not a lot of smooth curves or anything. Like this map is, you know, there's a lot of like crunchy, tight detail, but for the most part, this normal map is flat. And what that means is I can cheat this a little. Like I said, I'm doing a square root calculation here. And what I can do instead... Oh, you guys, this is super cool. Unity has not had an append node before, but now it does. So definitely take advantage of this. This is just like the append node in Unreal, and it helps save a lot of time. So please use the append node in Unity Shader Graph. So what we can do instead, what I've done is taken the X and the Y component of my normal and added it to an append. So now I'm adding one more component. So my result is going to be a vector 3. And instead of calculating an accurate Z, all I'm going to do is take my append and just append a 0.5. So I'm basically saying the Z is a value of 0.5. And I'm just not even going to do this normal reconstruct math. I'm going to skip that completely. And you might be saying, but how can you do that? Like, how can you leave that out? Like, that's not accurate. But the secret is, with these normal textures, because they're mostly flat, the value that you're computing for that Z component is mostly just 1. Like almost all of the values are 1 or very close to 1. And so just by appending a value of 0.5, we can get a pretty good approximation of what this reconstruct Z is doing without doing any of the math. It's pretty cool. Let me actually go ahead and show you the difference of what this looks like. So we've got our layer here. I'm trying to think of the best way we can do this little illustration. So I'm going to just save this layer. Here is our shader, and I'm going to drag in the layer, the subgraph that we just created. This is our simple layer. By the way, we're not completely done yet. There's more that we need to do, but let's just take our simple layer here and connect it up. So I'm going to put in the color, the normal. We don't need the metallic, the smoothness, and the occlusion. One other thing, by the way, this is a shader that I created called Test Terrain. And when you're creating shaders for terrain, you want to make sure that your graph settings here are set to terrain lit. This is brand new in Unity 6.3. You have this option to set your material type to terrain lit. So be sure that your shader is set to that. Okay, so I've set up my my simple layer here, and we're just going to assign that to our terrain. And I just remembered there is one thing that I forgot. We do need to unpack our normal by multiplying by 2 and subtracting 1. So I'm going to take my vector 2 data. I just kind of skipped over this, but what I'm going to do is I'm going to use this node that I've created called expand vector 2. I really like to use this kind of a subgraph here. It just makes things a little bit cleaner. But I'll just show you here really quickly what this expand vector 2 node is doing. It's the exact same thing as if I were to take this and multiply it by 2 and subtract 1. So if you don't have this expand vector 2 node, I have that one because I created it myself. But basically that just takes this multiply by 2 and subtract 1 and groups it into a single node to make things a little bit easier. Okay, so I've taken my X and my Y component and I've added this expand vector 2 node in here, which multiplies by 2 and subtracts 1, and that increases our range. Instead of the values coming out of our texture that are from 0 to 1, now they're in the range of -1 to 1, which is what we need for these vectors. And I'll save that. And now we've taken our subgraph. This subgraph here is the same subgraph here. And we've added our simple layer to output just its own simple material. And then we've applied that to our terrain. And so now you can see we're getting our nice terrain material here. And so what I want to do off screen, and I'm going to make this change. Well, actually, I could just tear this tab off. What I want to do is show you the difference visually between using this append node to just make our normal Z component 0.5 all of the time versus doing this extra math to do the normal reconstruct Z. So I'm just going to plug in our normal reconstruct Z here for the normal, and we'll save it. And watch over here really close. All right, did you see a difference? It's pretty subtle. Let's switch back to the cheap version without doing the math. This version is a little bit crunchier. Now, one thing that you can do here is the append value here can control the strength of the normal. So if I set this to 1, that's going to give me like the default normal, which is kind of like this. And then if I switch to the version that's doing the square root, that's doing extra math, that one's going to look like this. So if we want them to look exactly the same, we'll maybe set this to 0.8 to make the normal slightly more crunchy. Yeah, so now the results of these two are looking very similar, but this one is super cheap because I'm not doing the square root. I'm just skipping that math. And so we can save a little bit and improve our performance that way. Now, I prefer my normals to look a little bit crunchier, so I'm going to leave that at 0.5. We'll just plug our append right in here and go ahead and delete that normal reconstruct Z node. And now we are all done with our unpacking. There are a couple more things that I want to add to our shader here, so let's go ahead and do that. I mentioned here this matrix 4x4 that has our material all packed together. And I have a node here that's called pack material. And so what I can do, and you can see the output of that node is a matrix 4x4. So what I can do is just wire in my color and my normal. And again, we're not using metallic. I can wire in my smoothness and my occlusion and my height. And this node is going to pack all of those material properties into a single wire which is stored in a matrix 4x4, and then I can pack that, or I can pass that out. Now, this node, all it's doing is rearranging where things are stored, and so there's no extra math involved in this at all, so you don't need to worry about that. If I double-click on this, here's what that pack material subgraph looks like. Basically, it's just putting the color into the first row of the matrix, the normal into the second row, and then the third row of the matrix is packing the metallic, occlusion, height, and smoothness. And this is purely for convenience, so that your graph is a little bit cleaner. You can pass all this data around as just a single wire. This is a pretty cool tip. All right, the other thing that we need to do is make it so that our layer subgraph can be used for any layer. Right now, if you look over here, this index value that's coming into our terrain texture node, this index value controls which terrain layer we're getting the texture data from. And right now it's hard-coded to 0. And that works fine because the simple little terrain, the simple terrain sample that I just made only has one layer, so layer 0 is fine. But what I want to do is change our subgraph so that we can make multiple layers. So I'm going to come over here to my blackboard, and I'm going to pick the drop-down type, and I'm going to call this layer. And then I'm going to drag this in. Let's go ahead and define the values of our drop-down. Our drop-down is going to have the ability to do layer 0, layer 1, layer 2. And I'm typing these out because it doesn't allow you to use numbers. Layer 0, 1, 2, and 3. And so now I can drag this layer value in. And I want to make sure that when I'm passing in each of these, I'm giving it a 0, a 1, a 2, and a 3. And now I can pass these values into my terrain texture nodes. And depending on the layer that I select, it's going to give it either a 0, 1, 2, or 3 passing into that index value. So that's how you can make it so that your subgraph is configurable. So if we switch here to our test shader now, you can see that our little simple layer subgraph, now I have a drop down here and I can pick 0, 1, 2, or 3 to tell it which of my layers I want to get that texture data from. All right, and there's one more thing that I want to do. I actually want to add an input in my blackboard here for a sampler. Shaders are limited in hardware to a total of 16 sampler states. And what I want to do here is make sure that all of my layer shaders are sampling from the same sampler state, because eventually we're going to create a shader that has a bunch of layers, and each layer is going to have a bunch of texture samples inside. And I want to make sure that all of those texture samples are using the same sampler state. So I'm going to expose the sampler state here in my blackboard, and I'll come over here to my inspector, and just to increase the quality of my textures, I'm going to set my filtering to trilinear, and I'm going to set my anisotropic value to 16x. Now this is going to be the most expensive, and I'm just using this for demonstration purposes, but if you want to make your terrain shader cheaper, you can experiment with different combinations of these values. You could use linear instead of trilinear, and you could use different levels of anisotropic filtering. But mine, I just decided to crank it up and use trilinear and 16x anisotropic. That might be a little bit overkill, but it should be fine. All right, so now I can bring my sampler state value in, and I'm going to plug it directly into my two samplers. And now we can save this and switch back to our terrain texture. And now you can see my subgraph has that input for a sampler state. And so I can add a single sampler state here. And again, I'm going to set my filtering to trilinear. And I'm going to set my anisotropic filtering to 16x and pass that into this subgraph. And now what that guarantees is, like, no matter how many no matter how many layers I end up adding here, I can always ensure that I'm using just one sampler for all of the textures on all of the layers. Okay, so that's the simple layer that I've set up there. I'll hit save. We'll switch back to our terrain. And now you can see we've got our really nice dry earth soil material set up. And that same subgraph that we created can be used for, whatever our material is. So if I select my terrain here, and I say, well, I don't want to use the dry soil. I want to use the mossy material. So there's that one. I can also pick the rocky grass one or the stone ground. And all of these work just the same. So I've got all my materials set up. I have my simple layer subgraph here. And I've taken that subgraph and applied it in my shader. This is just really simple. But now we're able to apply those textures to our terrain. We unpacked all the data. We created our subgraph and we added that subgraph to a simple test shader, and it's working great. It's doing exactly what we needed it to. So next week we're going to get a little bit more advanced. I'm going to show you how to start adding multiple layers and blend those layers together and that sort of thing. It's going to be pretty cool. All right, but for now, let's switch over to Unreal and I'll show you how to do this same thing there. All right, here we are in Unreal, and as you can see, we've got our terrain set up just the same as we did in Unity with the same material, same textures. And I'm going to go through and show you how this setup is working. So I've got my terrain selected here. I guess, in Unreal, they call them landscapes, but, terrain, landscapes is kind of interchangeable term to me. So it says here, landscape material, and I've got my material here assigned to my landscape. So if we take a look at the material, you can see that I've got a material function here called simple layer. And I've got 3 inputs to this function, CR, NOH, and scale. And so I'm able to pass in different texture objects here. So let's go ahead and do that. I'll create 2 texture objects. And we can connect those up directly to our material function here. This one's going to be our color and roughness, and this one's going to be our normal occlusion and height. So here, I can just select my textures, and so I'm going to use dry soil CR for that one, and I'm going to use dry soil NOH for that one. So if I save this and we switch back to our scene, it looks exactly the same because the material function here that I'm going to show you in just a minute is using these 2 material or these 2 texture objects as default. And then for our scale here, you can see that we're passing in default values of 1,000 and 1,000, and that basically means Unreal is using centimeters as units. So these are going to, these are the default scales for our material. So if we wanted to scale it up or down, I could just hold down the 2 key and click, and that'll give me a value here. And I could give it a value of 2,000, for example, and pass that in. And if we save it there and then pop back, now you can see it's much larger because our tile is scaled up. Or we could give it a value of like 500 and save that. And now we've got much smaller scale. So we're able to control the size of the material with that scale input. Okay, well, let's go ahead and set this back to 1,000 where we had it. And let's take a look at our simple layer material function, and I'll show you how this is set up. So we're sampling our textures here. Here's our texture sample, the first one and the second one. This is our input for our color and roughness, and our input for our normal occlusion and height. So here you can see that we've named our input CR. We've set its input type to function input texture 2D. And I checked this use preview as default button. And that allows me to use this texture object here as the default input for this input to our material function. I've also set up our NOH texture, and it's set to function input texture 2D. And here's my texture object, the default texture object that I'm using, and that one's set to my dry soil NOH texture. Okay, so I'm bringing in the textures and I'm sampling them. And the texture coordinates that I'm using to sample are based on my absolute world position. And you can see that I'm using the X and Y output for absolute world. X and Y of our world position is basically like a top-down projection. So I'm projecting onto the terrain from the absolute world top-down projection, and then dividing those coordinates by my scale input here. So my scale input is set to function input vector 2, and you can see I'm giving it default values of 1,000 and 1,000. And even though it's set to vector 2, for some reason Unreal always gives me a vector 4 for the preview values, so you can just ignore the other two values here. Since it's set to a vector 2, I'm only going to be using these first two here. And then I've got this use preview values default checked. Now for my inputs, here's CR, and it's set to a sort priority of 0. NOH is set to a sort priority of 1. And scale is set to a sort priority of 3. I guess this should be 2, so because it goes 0, 1, and 2. So there you go. All right, so those are my texture coordinates that I'm passing in. And then over here in the shader is where I'm doing the unpacking. So my first texture sample here is the color and the roughness. And so you can see here I'm passing out the color. And I've got this node called set material attributes. And in Unity, I was using a matrix 4x4 for this, but Unreal has something a little bit more purpose-built. It has a struct with all of these individual attributes. So my set material attributes, I was able to set up the attributes that I want and then pass in my color, roughness, normal, ambient occlusion, and displacement. It didn't have one called height, so I just used displacement, but I'm passing height into that one. Okay, so when we're unpacking, we put our color into base color and also into our output color over here. Then we put our roughness into roughness and roughness in our outputs over here. And then for our normal occlusion and height, you can see I'm taking the red and green channels of our normal there and using this append node to combine them together into a vector 2. And then I'm multiplying by 2 and subtracting 1 to expand the vector to the -1 to 1 space. And then again, I'm appending the 0.5 value. And this is instead of reconstructing the Z component of the normal. I'm doing this because it's cheaper. There's a little bit of an optimization here. I could get higher quality if I used the... if I use this derived normal Z function here, this would create the proper Z component for me. But instead, just as an approximation, I'm using a 0.5 hard-coded value of 0.5. And that makes it so that I don't have to do the square root calculation that you normally would do with this derived normal Z. So, and the reason that I can get away with this is because terrain materials are generally fairly noisy and organic, and they don't need a lot of like precise calculations. And so I'm able to skip over this math here and just give it a hard-coded value of 0.5. It works really well. You'd be surprised how much you could get away with on terrain. All right, and then I'm passing out my occlusion here from the blue channel and my height here from the alpha channel. And I've got my output set up as a material, color, metallic, roughness, normal occlusion, and height. So that is a quick overview of my simple material function here. And you can see I've saved it and then added it to my terrain material, and then applied the terrain material to the terrain. And I end up with something pretty cool looking. It's pretty simple right now, pretty basic. There's not a whole lot to it. But in the next couple of weeks, we're going to be adding all kinds of cool things. I'm going to show you how to do several different methods of tile breakup. I'm going to show you how to do a couple of different methods of blending the different layers together. And we're really going to get into this topic of terrain shaders. I'm excited to go over this with you guys, and I hope you're excited to come back and watch the videos and learn with me. So that'll do it for this week. Thanks for watching, everybody, and have a great week.